four different modes that we actually see when both the region are forward biased, that is a saturation region. If one is forward biased, emitter to base region is forward biased and base to collector region is reverse biased, then it's a normal mode. If both the modes are reverse biased, then it is a cutoff mode, and if the base to emitter region is reverse biased and collector to base region is forward biased, then it is an inverted mode. Now let's look current flow mechanism in NP and BJT. Till now we were discussing the internal structure, internal charge flow of the BJT, but now moving from charge carriers, we'll be discussing more about the currents and the other parameters. As we have looked into charge carrier concentration and found that n electrons almost decreases linearly in the effective base width, and these gets combined with the electron hole pair in the process. Hence they have a linear decrease as they travel across the base width region. Now let's talk about the collector current. Collector current is the current IC in the collector region when the injected electrons minus those electrons which diffuse with the neutron in NP, and the injected electrons minus those electrons that diffuse with the hole to form electron hole pairs that reaches the collector region are termed as collector current. Now here also we can say that emitter base region is forward bias and collector base region is reverse bias. From earlier, as we have already discussed about the saturation current, the base current junction, and the collector current equation, how to get it, we have found that IC is equals to IS, reverse saturation current, e to the power VEB slash VT, where IS is the area, cross-section area, into charge, into diffusion constant, into NP naught is the charge carrier, and divided by the base width, where NP naught is equals to Ni square over Ne. They are the minority charge carriers. The saturation current doubles for every 5 degree rise in temperature. The collector current doubles for every 10 degree rise in temperature. The base current can be found by this formula. You can derive the emitter current, which is formed due to the breaking of the collector hole pairs and the dopant impurity which release holes in the region. These both phenomena combine to form emitter current. The emitter current parameter alpha, where alpha is a common base current gain. Operation in saturation mode. In saturation mode, a BJT has VCE equals to 0.2 volts and IC is less than IC sat. These two equations helps one in determining the current and other parameters in saturation mode. A collector base reverse current is the current flowing through the collector base region in reverse direction when the emitter is open circuit. ICBO doubles for every 10 degree rise in temperature, and ICEO is 1 plus beta ICBO. Then ICEO is greater than ICBO. Now this